Hey guys, welcome to day 23 of Codeforces Every Day until GM. Running a little bit late today, so let's just hop right into it. We're doing another problem on the A2OJ ladder. It's called Panoramics Prediction. Prime number is a number that has exactly two distinct divisors, one in itself. For example, numbers 273 are prime and 164 are not. The next prime number after x is the smallest prime number greater than x. For example, the next prime number after 2 is 3, and the next prime number after 3 is 5. Note that there's exactly one, blah, blah, blah. So 5 is not the next to 2. Okay. So, one cold April morning, Panoramics predicted soon that this person will break free of his straitjacket and this will be a black day for the residents of Gallic countryside. Prophecy tells that if someday these people beat exactly X Roman soldiers where X is prime, and the next day Y, where Y is the next prime, then it's time to wait for Armageddon. Nothing can shut this person up when he sings his infernal song. Yesterday beat in, and turns out it was prime. Today their victims are a troop of Roman soldiers. Romans determine whether we should wait for Black Day or not. So basically check if N and M are back-to-back primes, right? So first of all, how do we check if a number is prime? I do remember seeing an equation for this in a Discord server before. Let me see if I can find it real quick. If not, then whatever, but... okay. No, it's just a mod tip. But... okay, so... N is always going to be prime. Check if M is the next prime. So a prime number is a number that's divisible by itself and 1, right? So how do we check next prime? What is the best? Okay, so obviously we need for I in range. Wait, no. Is M the next prime after N? So, okay, so Excalibur. We basically need to check, is M prime? Is there any prime between N and M? Right. Now the question is, how do we check prime? Okay, Python. How to check if number is prime. To check if a number is prime in Python, the most common and efficient method is using a trial division loop up to the number's square root. So a number is prime if it's greater than or equal to 2, has no divisors between itself and 1, oh, I get it. Because if we only check up to the square root, okay, say our number is x equals 8 times b, then a or b has to be less than or equal to square root of x. Right. So basically we just check for I in range from 2 because 2 is prime int. We're not using x in this case, we're using m. We have to check if m is prime. M 0.5, so this square root. Make this an integer plus 1. And then if can we just make this a method like def is prime? For I in range num, and then if num mod I is equal to 0, then return false. Else return true. Okay. So next prime is equal to n plus 1. Checker equals call this prime between equals false, and then while next prime while is prime next prime while not is prime next prime if while not is prime next prime, then next prime, let's name this next num. Next num plus equals 1, and if next num is equal to m, print yes, else print no. So basically what we're doing here is we define this as prime function. We check prime by checking all the numbers below the square root of that number. If it's modulus of one of these equals to 0, then we return false, because the modulus of, if a number is prime, then it's only divisible by itself and 0. If it's divisible by another number, which means no remainder, then it's not a prime, and return true. And then we define next number as n plus 1. So n is the first number, so we check the next number. We check if there's a prime between, wait, we don't even use this. We don't need that. And then while is prime returns false, because not will make it true. We're checking the next number. We can keep checking the next number. We're basically just incrementing this until the next prime. If the next prime is m, then we print yes, else we print no. Okay, yeah. Programming, Python, Codeforces, save. Oh, I didn't even run it through the inputs. It doesn't matter. I think we got it. There we go. Okay, that question wasn't easy. It was, okay, we need to memorize this, like this is prime function. And I'll check with my buddies to see if there's a faster way of doing this, but from quick Google, this is like the way to do it. I'll just message right now. Oh. To check Okay, we'll see if he responds by the end of this video. In the meantime, let's do the next problem. Well, I gotta make sure I don't do over problem 100 because I'm gonna make a YouTube video soon that's like my progress and whatnot, you know? Maybe I'll make that video tomorrow if we can get there. We are at 98 problems. So 2 more problems and I can release the this is what doing 100 Codeforces problems did to me, you know, type of video. Hopefully y'all will enjoy that. So look forward to that soon. In the meantime, do the next problem. What rating is 800? I don't want to do 800. Let's do a harder one. 1000? Yeah, let's do that. 450A. Just who and children. Dot pi. Rating 1000. There are in children in Jesu's school. Give them some candies. Let's number all children from 1 to n. A child wants to get at least AI candies. Line up, the odd child stands at the odd place, then Jesu start distribution of candies. He follows the algorithm. M candies to the first child of the line. If the child hasn't got enough, then it goes to the end, else goes home. Repeat first 2 steps while not empty. Wants to know which child will be the last. Okay. 2 integers in m equals map int input split. And then second line is a list. Here we go. Now, what are the rules? Give m candies to the first child, and then doesn't have enough, go to the end of the line. Okay, so it's a queue. Our queue is A. So for I in range A, range n. Okay, so while. Let's use while loop. While which child will be the last? While len A is greater than 1. Oh, we have to keep track of their indices too. Okay, so let's implement a queue equals A. And then while len q is greater than 1, we run this while loop. And then Q0 minus equals M if Q0 is less than 0, less than or equal to 0, then Q dot Python pop first element of array. Dot pop 0, Q dot pop 0, else wait, Q shouldn't be a copy of A. Q should be the indexes. So Q should be the indexes of A, so it should be 1, 2, 3, 4. So we can create like this, list range in print Q. Let's see how this works. Okay. While the length of Q is greater than 1, if A Q 0, okay, AQ0 minus equals M, if AQ0 is less than or equal to 0, Q dot pop 0, else to append equals Q dot pop 0, Q dot append to append. Print Q 0. So, okay, so if I'm understanding this correctly, this should be how it works. So it's -2, he's popped, -2, he's moved to the end. Okay. It's 2 candies go home, 2 candies go to the end, so it currently looks like wait. First samples this. Go home. Where's 5? Huh? Huh? Am I missing something? Second child gets 2 candies and goes to the end of the line. So wants 1 more, so it's 1, 4, 2, 1. Oh, these are indices, right? So 3, 4, 5, 2. Yeah. Third child gets 2 candies, go home. Yeah. Fourth child gets 2 candies, goes to the end of the line. So it's 5, 2, 4. Okay, yeah, I think, yeah. Okay, something's not right. And if I were to predict, this is going to give 5. Yeah. So it's because our indices start at 0 and not 1. So we just add 1 at the end. 4, 6. Okay. Browse. Choose your own children. Submit. Let's go, Codeforces. Oh, very slow today. Should we do an even harder question? This time looking like 27. Do maybe like a level 3 question. Is that too hard? 1200. We can take a look at it. Oh, and accepted. Alright. Reload this, 99. So this is problem 100. 445A. DZY loves chessboard. Okay. Let's take a look at this question. DZY loves chessboard. He enjoys playing with it. He has a chessboard in rows and columns. Some cells of the chessboard are bad, others are good. For every good cell, DZY wants to put a chessman on it. Each chessman is either white or black. After putting all chessmen, DZY wants that no two chessmen with the same color are on two adjacent cells. Two cells are adjacent if and only if they share a common edge. Your task is to find any suitable placement of chessmen on the given chessboard. The first line contains two space-separated integers n and m. Each of the next n lines contains a string of m characters. The jth character of the ith string is either period or dash. Wait. Wants that no two chessmen with the same color are on two adjacent cells. Two cells are adjacent if and only if they share a common edge. Your task is to find any suitable placement of chessmen on the given chessboard. The first line contains two space-separated integers n and m. Each of the next n lines contains a string of m characters. The jth character of the ith string is either period or dash. A period means the corresponding cell is good while dash means bad. Output must contain n lines. Each line must contain a string of m characters. Jth character either white, black, or dash characters. White, black, bad cell. Multiple answers exist. Print any. It's guaranteed that at least one answer exists. Okay, so first things first, we take in this. Oh, copy, paste. And then next, okay, in m, string of m characters, okay. So what does he want to do? He has a chessboard. For every good cell, wants to put a chessman, white or black. No chessmen with the same color are on two adjacent cells. Two cells are adjacent if and only if they share a common edge. So what does period mean? What does this one mean? Period dash period. Period is a good cell. Black. Okay, so bad cell, so nothing can go on there. Right. So in this case it's black, white, white, black. All these are adjacent. And these are bad cells, so black can go next to black. Black. This could also be black, white, white, or whatever, right? First sample, put the single black. Of course, putting a white one is also okay. Second sample, all four cells. No good cells are adjacent, so you can just through whatever. Okay, this question is really hard. I can already tell because I can't see an obvious answer to this. Let me think. How would you start with this question? If it's good. Okay, well, first we need to take in some input, right? So for in for in range in row equals stir input. We can turn it into a list if we want. Okay, wait, do I need to stir here? Or can I print row, save? Okay, I don't need that. So we can take in the input now. Now how do we modify it so that let's take in all the input. Board equals this board dot append row. Okay, that worked. Now that we have our board, how can we adjust it? Oh, let's put this problem on pause real quick and go back to the prediction problem. Pull this up. I got no response from my buddy. So, what did he say? Sieve of Eratosthenes, or you can just do square root brute force. That's what we did. We did square root brute force because that's what Google told us to do. Now we can look up this other definition, see what it says. Okay, he spelt it way wrong. Eratosthenes. Ancient efficient algorithm for finding all prime numbers. How it works. List of consecutive Python. This. Okay, I've written an implementation in Python, but it's terribly slow. Initialize the prime list. Create a Boolean array. Initialize all as true. A value will be false if it's not a prime, else true. How it works. Initialize. Set all to true except for 0 and 1, which are marked as false. Start first prime, iterate through the list from p times p up to n, marking every multiple of p as false. Move to the next number, still mark true. I see. Okay, that makes sense. Oh well, okay. Back to this problem. Did that help us with this problem at all? Nope. Has nothing to do with primes. But, oh, oops. Okay. Where were we? Okay, we have the chessboard now. Just kill all these open instances that we don't need. And then okay, so white, black, black, white, white, black, black, white. If it's just one dot, it's just white or black. So we can just always pick white or black to be first. So let's just say we pick black to be first. At the first occurrence of period, we always pick black. And then let's say some dashes. Next first occurrence, pick black, white, 1, 2, 3, 4, 5, 6. So if these were all period, then this would have to be white, black, white, black, white. Wait, but then if it is, that doesn't work. Wait, so white, black, white, black, white, black, white. And this would have to be white, black, white, black, white, black, dot, dot, dot. If this was dash, if these were dash, okay. Wait, oh, so basically we just like follow this alternating pattern. We make sure that it's black, black, white, black, white. And if it's dash, we just leave it as B. So for row in board, for row in range, and for call in range M, per okay. Our current value equals black if board RC is equal to period board RC equals current. And then if current equals B, current equals W, else current equals B. So this is our swapper, this is our replacer, and then print current, or print board. B. VWBW. So that's not it for this row. So for each row. So if row is even, if R mod 2 equals 0, current equals B, else current equals W. B, BWWB, in this case, VBB. Alright, now I just need to print it for row and board. Print dot join board. Or wait, I did a question earlier today that required something. Well, let me see if I can find it. It required something similar. So lights out. Yes, it was. It's like you need map or something. Or okay, Codeforces is being real slow. Like yeah, this is what I'm looking for. For row and board. There we go. Come on. There we go. We did it. That is officially question 100. Right, let me just double check. Yes. Blur out the email again. Would you look at that? 100 problems for the last month. Okay, well, if you enjoyed this video, be sure to like and subscribe. I'll see y'all guys tomorrow.